We are praying, Heavenly Father, we thank you, Lord, for this morning. We pray that you be with us, give us wisdom, understanding, and knowledge. We commit this demo session before you and the graduation and matriculation sessions before you, Lord. We pray that you have your way in our midst, and we decree that everyone that is matriculating, Lord, will go through this course successfully, and all those that are graduating, Lord, we decree that they shall all leave landmark with the joy that every other person have had. Thank you, Lord, because you know you've answered in the name of Jesus. Amen and amen. Okay, thank you so much, everybody, for being part of this session again today. It's an interesting session, which we are going to be discussing on what DevOps is all about and why you should be able to be part of this great IT journey. You know, why you should be part of this great IT journey, particularly with the evolution that's happening around the world today. You know, things are changing and everything is, you know, being deployed from a strong engineering position. So why is it important? Why is everybody doing DevOps? Why is everybody not only doing DevOps, but joining the landmark global family? That's some of the things we'll be able to look at carefully. So again, my name is Prof. Lega, Simon Lega. I'll be taking you guys through this demo session today. For those of you that are meeting me for the first time, this is demo number 35. So this is a 30-feet batch of students who will be going through this demo session. But importantly, what are we talking about when it comes to the DevOps end-to-end program? So generally, we'll be talking about the DevOps, you know, what is DevOps all about? And why is it important for you to be part of this great DevOps journey? Those are some of the things we'll be able to look at today. I know we have folks connected from around the world, and the main question is, why DevOps? You know, why is it important? Why is everybody talking about it today? There are some of the things that we should be able to look at with relative ease. I hope you can see my screen at this time. Can you confirm if you're able to see my screen?
Not yet, bro.
Can you see my screen, everybody? Okay.
No, not yet.
Can you see now?
Yes, Prof, we can see your screen now.
Okay. Now mute everybody. You're not able to unmute yourself for now, except for the administrators, we should all be on video as well. So we are talking about DevOps EDB Master Program. And one of the things we'll be talking about, we get to do with, you know, Why DevOps? Why DevOps? Why is it important? So we're looking about why. Why DevOps? Why study DevOps? Okay, now who's DevOps engineering? Why study DevOps engineering? Why study DevOps engineering? What is we have under this? Cloud engineering, or what you can call cloud computing. Okay, why study IT? Why study IT? Why study let me just measure on this two for now. Why is it important to have to study this particular concept today? Why is everybody embracing no audio? Can you hear me? I'm getting comments like no audio.
We can hear you.
Okay. Now, why study this? Now, if you look at when we talk about DevOps today, we are basically looking at how software development has evolved. So how we call software development life cycle. Software development life cycle. How SDLC. Now we have software development life cycle, SDLC. How has it been able to develop? And you may want to find out what is a software? Why is it important? Okay. What is a software? What is it important? Now, when we look about software, we are talking about, an application, software is like, we can create software to what we call application development. Software development is like application development. So you can work as, when you're done with this course, you can work as an application engineer. So it's all about application engineering. Application engineering. That's one of the things to look at. So we have application engineering. So now, why study application engineering? Why study IT? Why study cloud computing? Why study DevOps computing or DevOps engineering? All of these are questions we are going to be able to answer by the end of today. Now, you realize that daily around the world, everybody wants to make their life easier. So now, the ease of tax management, or the ease of managing and completing tasks, okay, is vital. Now, the ease of managing, the ease of completing tasks is very vital when it comes to general living. For example, if you are given a job that you can take about 10 hours to do that job, if you're able to do that job in 2 hours, aren't you excited? Now, you have a job. Okay, now, or if you give a job, let's assume you give a job to somebody or to 2 people. You give the job to Simon. Simon took 10 hours to finish the job. Now, you gave the job to Paul. Paul took 2 hours to finish the job. Now, who is more efficient in terms of time management? Of course, it is Paul. So increasingly, there is need to complete tasks quicker. Okay, so by virtue of this, increasing need for speed in accomplishment, okay, we have what we have been able to observe in the IT world today, which is what we call automation. Okay, now we have automation. So now we are going to be talking about automation engineering. These are the things we'll be looking at throughout this course. Automation engineering. Now, automation, automation has evolved. Automation has evolved. Okay, today we have AI, artificial intelligence, AI. Now, such that if you were going to write a letter, for example, you can have an artificial intelligence. We have softwares that can write you an application, a very good application, can write a book, can do a lot of things. So there is a lot of artificial intelligence being deployed to production. Therefore, now, how do I, because again, now, generally, there are two people in the market. In the market, we have consumers. Who else do we have in the market apart from consumers? What are consumers consuming? Producers. So we have producers and consumers, okay, of applications or IT resources. So for any application, we have those that are producing the application, those that are consuming the application. This includes be it AI, whatever it is. There are those that are at the back end producing this application, developing it, making it available for consumers to consume. Now, it's just like when you go to a football field, you have those that are generating the fun, those that are the key players, and those that are just spectators. Now, you and I know who goes home with a lot of money. Is it spectators or key players? Is it consumers or producers? Who goes home, okay, with the greatest satisfaction? Is it those that are just watching the match and they are happy and commenting, or those that are participating? Of course, those are participating. So therefore, today, now it's just like you have a child. Okay, now, children love to watch cartoon. I hope that's the right spelling. Cartoon. Now you have Cartoon Network. Cartoon Network. So you have Cartoon Network channels that children will want to watch cartoons. Now, do you know that you can decide either to be somebody that's watching cartoon, okay, to somebody who is developing cartoon. So can you decide that your child, okay, now that you love cartoons a lot, I want you develop one cartoon, okay, and can they do that? Of course, today we are going to realize that all of those things are available. But now let's look at something. Let's see how things have evolved when it comes to IT. We are talking about software development, how these softwares have been developed, or how applications have been developed. So software development is about application development. Software management is about application management. Now, when it comes to developing softwares, there have been an evolution over time. And that's what we'll be discussing. Software development life cycle. How has it evolved? How was it done before? And how are they doing it today? Software development life cycle. So when it comes to software development life cycle, you come to realize that before, okay, now there have been an evolution. Okay, so in the software development life cycle, it has evolved from what we call the waterfall approach, waterfall to agile, okay, from agile to DevOps. You see that? Now, it has evolved. Software development life cycle has evolved, okay, from waterfall to agile to DevOps. And that's what we're going to be able to discuss again in this first part of our discussion. How does the waterfall approach work? Software development lifecycle waterfall. Okay, now how does the waterfall approach work for software development lifecycle? Now, we have a company called Landmark. This is Landmark Technology or Landmark Tech. Landmark Tech is a software, okay, we have Landmark Software Solution. This is Landmark manufacturing software. Landmark has a customer. Okay, Landmark has a client. Who is this client? This client is PayPal. Now, so Landmark is developing software for PayPal. Okay, so this is what we got. We have Landmark developing software for PayPal. Okay, let's discuss how this is going to be able to be achieved from end to end. So on one side, we have Landmark. On the other side, we have PayPal. Okay, we have Landmark and we have PayPal. Now, let's we look at this as our case study for today's discussion. We have Landmark and we have PayPal. So now, when we use the waterfall approach to achieve this process, what happened is that Landmark need to understand what PayPal wants. What kind of application, what kind of software do you want us to develop? That's a key question to answer. Once that question is asked, okay, the next thing is that now, PayPal needs to answer that question. So there will be kind of a meeting with PayPal, and that meeting will be for us to understand the requirement. Which kind of software needs to be developed? It's which kind of software? Is it an e-commerce software, payment gateway, whatever it is? So now, information has to be gathered. For this information to be gathered, okay, what is involved? What is involved here is that we're going to have our architect, okay, and team lead will have a meeting with the client. So these are the members of our team that will be able to sit down with the customer to understand what they want. Team members, architect and team lead. Now, once they understand what they want, okay, the next thing is that we have, okay, phase two. Phase two will now be design. Phase two is design. So now we need to design what is needed. What is it that is needed? Okay, it has to be designed. That's phase two. So phase two is the designing phase. So in this designing phase, okay, what is involved? What is involved in the designing stage? What is involved in this designing stage? Now, in this designing stage, we are going to kind of understand the kind of computers that the application will run on. So we come up with what we call high-level documentation and systems requirement. What is required? Systems requirement. High-level documentation and system requirement. They will be involved in this stage. Now, once we have documented everything that the client wants us to do, we go to the next stage. Now, what is involved in the next stage? In the next stage, we start developing the application. We call it implementation. Okay, who are those involved here? Our team of developers. They start writing the code. Developers. So now, developers are involved in this stage. So we are developing an application for a client called PayPal. Now, once this application is developed, okay, the next thing that follows, it needs to be tested. So it goes through testing. It has to be tested. And what are those involved in this testing stage? Our QA guys. So members of our QA team, quality assurance, okay, they'll carry out testing. Now, if they test the application and they are satisfied, what happens? It has to be deployed. So after it is tested, we have what we call deployment stage. It needs to be deployed. Deployment is taking it to the market, taking the application to the customer. In this case, our customer is PayPal. Now, who are those involved in this stage? In the traditional approach, we have guys called middleware admins. So middleware admins, these are the guys involved in this stage. They deploy the application. Once the application is deployed, okay, it means that it has been taken to the market. But now, what happens if there is a problem? We have a maintenance stage. Maintenance. If there's a problem, the maintenance stage is going to get that problem fixed. This is how the waterfall approach works. Now, who are those in charge of this stage? Who are those in charge of maintenance? These are our support guys, support team. So the support team are in charge of maintenance. Now, if you look at this approach, this is a very interesting approach. Okay, but now, if you deploy this application and there is a problem, we will have to repeat the entire stage. So what are some of the problems with this waterfall approach? What are some of the flaws? What are some of the flaws? Number one, it's time consuming. It could take, for time, it could take from 4 to 6 months. You see that? It could take from 4 to 6 months. That's too much. So these are some of the limitations. And if it takes that time and there is a problem, we may have to repeat it. Now, the next thing is that we have poor resource management, poor resource utilization or management. Now, how are the resources here managed? It's very poor because when developers are implementing, our QA guys are doing nothing. Middleware guys are doing nothing. You see that? So if you look at the way the stuff is, you know, the entire team is not engaged at once. And since they are not engaged at once, okay, what happened is that okay, since both are not engaged at once, it means some of the resources are idling. Poor resource pressure. So this is the traditional approach, okay, with all its limitations. Now, which other approach has been tried? We have here agile approach. We have agile approach. With this agile approach, okay, we'll talk about the Scrum framework. Scrum framework for agile. So for this agile approach, we have the Scrum framework. Now, this has taken automation at least to a certain level. So with this approach, what happens is that now development takes place in cycles. Okay, so when it comes to this approach, development takes place in cycles, agile approach. Or we have, so, you know, here we developed in iterations. This iteration, we call them sprint. So now, when it comes to this approach, if you look at this, the agile approach, this could take us up to 6 months. And once it takes 6 months, there is always a problem. Because if it fails, we could repeat the time cycle. Research as well is very poor. But here we develop in iterations called sprint. So now, so a sprint is a development period or cycle. That's how we're going to look at the sprint. Now, So sprints generally last for 10 working days. So if you have a sprint, it generally lasts for 10 working days. Now, let's see how this agile approach works. We have a development period, which is going to last for 10 working days. Now, we are working with paper. So what do we do? Now, look at what we do. To start with, we have a team, okay? Who are the members of our team? We have them. Let's assume we have 4 developers. 4 developers. So we have 4 developers. Now, we have 2 DevOps engineers. 2 DevOps engineers. Okay, 2 DevOps engineers. We have 1 guy for QA, 1 QA guy. Okay, we have a Scrum Master, 1 Scrum Master. Now, these are members of our team. Maybe we have 1 person who is in charge of security. We have a DevSecOps. So these are our team members of the team. So let's see how this agile approach works. So the agile approach is very good because it supports meetings. So we have here meetings. Now, so when a production period is going to start, the way we call a sprint planning meeting. So we have here a sprint planning meeting. This is the first meeting that is held. So now a meeting is held. We have 4, 8, 9. Okay, let me add another person, lead. So we have a team lead. So our team is a total of 10 individuals. Now, there are 10 people in the team. So now we are developing an application for a customer called PayPal. We have 10 persons in our team. So we have a sprint planning meeting. Now, this is sprint 1. What are we going to be doing in this sprint? In this sprint, the application we want to work on, okay, we can work on sprint 1. So now we have sprint planning meeting for sprint 1. So sprint 1, we sit down, check our resources, and decide that we are going to develop 8 features of the application based on the resource that we have. And what is our resources? 1, these are the resources that we have, members of our team. So based on the resources that we have, okay, we decide that based on what we have, we can develop 10 applications. Or not 10 features, no 8 features of our application. So in sprint 1, we are working on 8 features. Based on our sprint planning meeting, 8 features. Now, we are finished with sprint 1. We want to start sprint 2. Do we just jump into sprint 2 with the agile approach? Of course, there's going to be a sprint planning meeting for sprint 2. But before this sprint planning meeting for sprint 2, we are going to have a sprint retrospect review meeting. Retrospect meeting for sprint 1. This retrospect is review. We want to review what happened in sprint 1. So this is the agile approach. So we have the sprint retrospect meeting. Okay, for sprint 1. Now, once we review in the retrospect meeting, we ask ourselves questions like, okay, now, what were we able to accomplish in this sprint? What are the lessons that we learned? What is it that we did that we could do better? That is sprint retrospect meeting. Now, once this meeting is held, okay, the next thing that follows is that we now start planning for sprint 2. Let's assume that for sprint 2, we ask ourselves how many members of our team are available. So sprint 2, do we have all our team members available? Now, let's observe something. So in sprint 2, the members of our team, probably 1 developer is sick, so we have only 3 developers.
So we have one developer, okay, is not available. So in our sprint planning meeting for sprint 2, we realized that based on the resource that we have, we can only develop about 6 features, no longer 8 features. So we start developing this feature. So we are now working on it. This is, okay, the Scrum framework. This is how it works. Now, we have the sprint planning meeting. We currently have for meetings at the end of the sprint. What are we going to have? We will still be having sprint retrospect meeting for sprint 2. But now, with this approach, we also have what we call daily stand-up meetings. Daily stand-up meetings. So they are daily, okay, stand-up meetings. Daily stand-up meetings. This meeting usually lasts for 15 minutes. Daily stand-up meeting will last for 15 minutes, where, we are going to, the members of the team will gather and ask, okay, what did you do yesterday? What will you be doing today? Did you do all you had to do yesterday? Was there a problem? Do you have any obstacle? Were there bottlenecks? Was there a blocker? Do you need any help? Those questions are asked every day. Okay, so please take note, it's very important. These are the different stuff to be considered. But now, what is the problem? What are some of the flaws of this approach? That will be taking us to DevOps very soon. What are some of the flaws of this approach? Now, there's this stuff. The problem here is that team velocity is very high. Team velocity here is high. For example, when our number of developers dropped from 4 to 3, the number of features that could be developed equally dropped. Why? Because team velocity is high. And this problem is going to be solved as we look at the DevOps approach. Now, let's talk about the DevOps approach. You see that? And again, even when it comes to time, this approach equally takes a lot of time. It's equally time consuming. Team velocity is high and it's time consuming. So more time is needed to deploy this approach. And you and I know that if you have a job that can be done by 3 people, you have DevOps can do the job. Okay. Now you have a job that Waterfall can do the job. Agile can do the job. Now, Waterfall is going to take 26 weeks to do the job. Agile is taking 2 weeks to do the job. DevOps is taking 2 hours to do the job. Okay, the same job. Look at something. Now, who are you going to choose to do this job for you? Who will you choose to do the job for you? DevOps is going to take 2 hours. Or let me even be, very prudent. DevOps is taking 2 days. Now, this guy is taking, 26 weeks, 2 weeks, 2 days. Who should do the job? Of course, Mr. DevOps should do the job. You won't be going for the guy that is taking so much time. The same accomplishment. Now, so let's see why the DevOps guy is our choice. So we have here DevOps Automation. Let's see how powerful DevOps is. So now we have our client, okay, which we are working for. This is Landmark Software Solution, working for PayPal. That's the client. PayPal. So PayPal is the customer. So in Landmark Software Solution, we have our team of developers. So what are developers doing? These are developers. What is their job? Their job is to write code, develop the application, implementation. So these guys are writing code. You see that? That's their job. So they are writing code. They are in charge of implementation. That's their job. So what do we expect them to do? Now, when they write code, we have a team of developers. Developers, they are writing code. And when they write code, what do we expect? Now, when they write code with DevOps, the code is going to be committed to a source code management platform, in this case, GitHub. So we have here GitHub. This is a source code management platform. Now, there are many other source code management platforms that we could look at. Like we also have GitLab. We have GitLab. We have Bitbucket. Okay, now these are source code management platform. So when they write their code, developers are going to commit this code here. This is what they do. So they write the code, and the code is committed in this, central repository. Okay, these developers are working. Now, this source code management platform is distributed such that if a developer did some job and was not at work, okay, other developers can just proceed from where he or she ended. And what are they writing here? You come to discover that they are writing what we call the source code. They are writing the source code or the code. Okay, that's what developers are writing. Now, a part of the source code, developers are writing stuff like the test cases, because whatever is written has to be tested. They are writing the source code, they are writing the test cases, and these guys are also writing what we call the project file, the build script. They are writing the project file, developers, and all of it is committed here. Now, when they write all of this application, because they're developing software, when they write it and they commit it to this source code manager, this is a code management platform, SCM. Now, once it is committed here, okay, now we have another tool that is going to help in automating the end-to-end process. And that tool, as we're going to be studying in this course, is called Jenkins. So this is Jenkins. Okay, so now, what is Jenkins going to be helping us to accomplish? So Jenkins here is used for what we call continuous automation. Okay, continuous integration and continuous development. All of this, or continuous deployment or delivery, all of this is all about automation. Now, when this code is developed, once it is developed, Jenkins is going to pull the code. So the first step here is that developers are developing. Once they develop, Jenkins is going to collect what has been, what has been developed. So once Jenkins pull the latest version of the application, what happens is that it has to go through a build process. So we have here what we call test and build. Okay, it's going through a test and a build process. So here is stage 3, which is test plus build. So this is what is going to be happening here. Test and build. So once it is tested, so now we have a tool here called Marvin. So Marvin, we can use Marvin. We also have AND. We can use AND. Now these are tools that will help us to perform what we call unit testing and to do a build. Now the fact is that when this application is developed, the intention is to take this application to the customer. So Jenkins could have pulled the application and deploy it to the customer, who is PayPal. So this process is called deployment. Jenkins could have just deployed the application. Now to the customer, this is what we have the application savers, app saver. Now, so Jenkins could have just taken this application to the customer. But now what happens is that This application that is developed by developers, the form that it is developed is a raw code. It cannot be understood by this customer or client app savers. So what happened is that it has to go through a build process. Now, in building, it's going to be tested and packages will be created. For example, in our environment, we are managing Java projects. So in our source code management, our projects are Java projects. So we are managing Java projects. Since they have Java projects, it will create some packages, Java packages, that will end with either app.jar, app.jar, or wa, or here. Now, these are the packages. So it's either app.jar, app.wa, or app.here. These are the packages. But observe something. Now, these packages that have been created, they are now good enough to be deployed. But we will not deploy at this time. Because even though these packages are deployable, we have to qualify them to make sure that what developers have developed is a quality software. How do we achieve that part of the backend? For us to achieve that, we are going to use a tool which is going to qualify this code. So we are going to perform what we call code quality. Code quality analysis. So we have here code quality analysis. This is going to be performed. So another tool will be used to perform that. And that tool is what we call SonarQube. We'll be using a code quality analysis tool called SonarQube. We also have Sonar Clouds. Now, these tools are used to perform code quality analysis. Now, observe something. If the code quality analysis comes out positive, it means that our developers have developed good software that can be taken to the customer environment. But now, if it is negative, developers will be informed, hey, fix what you did, please. Can you fix what you did? There are issues. Fix what you did, there are issues. Now, our team of developers are going to be notified that there is a problem. Get it fixed. This is paper. Now, but observe something here. The fact is that while we are deploying this application to the customer, if everything is fine, we now deploy to the customer. This is stage 4. Stage 4. Now, if everything is fine, we need to deploy to the customer. But the problem is, while deploying the application to the customer, if something happens with our artifact, there's going to be a problem. So we have one more stage that we call, we upload the artifacts, we back up the artifacts, upload packages, artifacts. So now, these guys here, we call them either packages or artifacts. Packages or artifacts. Artifacts. So the artifacts are created. You see that? Jar, wa, and ear. Take note. So now, but before these artifacts are deployed to the customer, we have to back them up. And how do we back it up? How are they backed up? How do we back up artifacts? How do we back them up? Now, we use a tool, this artifact. We use another tool called, these are artifacts, Artifactory. We use Nexus, or we can use JFrog. We can use JFrog. So these are artifacts that are backed up. Therefore, how many locations do we have our artifacts? How many locations are our artifacts now? They are located in Marvin and in Nexus. Therefore, if you are trying to deploy to the customer from Marvin and something went wrong, can we get the artifact from Nexus and deploy? Can we collect from it? Yes, we can. So this is a backup process. Now, once this application are ready for deployment, okay, they are now in Nexus, then we can now deploy the application. This is stage 7, not stage 6, deployment. So deployment is taking place to the customer. So we are deploying this application to the client. So now this is paper. Now let's assume that this application is being deployed, this App Saver 1 is being deployed to serve 10 million customers, or let me say 5 million users. So this application saver can serve 5 million app savers. Now, if paper is having up to like 15 million users, what will happen? We'll need multiple app savers. We'll need multiple application savers. There will be App Saver 1, App Saver 2, and App Saver 3. This paper app saver. So this is a client. Okay, paper app saver 1, paper app saver 2. So this is a customer, paper app saver 3. Now, but I want you guys to understand something here. These are the application savers of the customer. Now, we need to be able to ensure that this can be deployed to the customer, via an automated fashion. So we are going to introduce another automation tool. Okay, this time around, that automation tool is no longer Jenkins, it's called Ansible. So we have here Ansible or Universal Code Deploy. So we can either use Ansible, we can use Universal Code Deploy. There are other tools. Now, with the help of this tool, this guy is going to automate the process of now deploying this application. Even if there are 100 or 1,000 app savers, okay, this tool will automate this process so that, it can deploy to all the app savers at once. At once. This is automation. But, okay, seamlessly. This is automation. This is how automation works. So with this, we are able to deploy our application. And if for some reason, something goes wrong with this deployment, the applications are running in the client's environment, and something goes wrong, can it be fixed? The answer is yes. So since something can go wrong, as part of this deployment, we have another tool that is going to do what we call, application performance monitoring. So we have an application performance monitoring tool. Okay, and this application performance monitoring tool are stuff like New Relic. We have App Dynamics. We have App Dynamics. We have Nagios. We have Prometheus. Now, these are examples of some application performance monitoring tool that we can use. So now, if something is wrong with this application, this guy is monitoring our application savers. If something is wrong, okay, it's going to immediately notify the team that, hey, something is wrong. Now, so how would the team be notified? How can we get the team notified if something was wrong? So now, if something is wrong, okay, we have another tool that does ticketing. Okay, ticketing and bug tracking. Bug tracking. Now, this tool, we are going to use Jira. So if something is wrong, we use Jira. Jira is going to help for ticketing and bug tracking. So a ticket is going to be raised. And once that ticket is raised, okay, our support team are going to be involved. So the support team, you see that, will now be involved. So via Jira, the support team. So we are creating tickets. You see that? So the support team will ensure that whoever needs to act on this ticket is able to act seamlessly. You see, if it's developers, they should be notified. So this is what happens in real time. This is DevOps. And with all of this, right? Now, with one click, this entire process is deployed to production. It's taken to the market. Now, let's look at something here, please. This application you see here is when we are managing a kind of an application that is not containerized. In today's technology, we have containerization, where we can containerize our application and manage them as containers. Very good for microservices. If we are doing that, then when it comes to Ansible here, we won't have Ansible. We are going to have Docker and Kubernetes. So with the help of Docker and Kubernetes, we can manage in the case where we are managing a microservice-like application. So please take note. So this is how the DevOps model works with relative ease, such that with one command, all of this can be deployed. And this takes hours, not days. So the DevOps model takes what? It takes hours. It doesn't take days. So please take note. It's very important. So this is the DevOps end-to-end life cycle for you to take specific note of. Okay, now let me just add a few things that you need to understand again. So we have just seen the DevOps e-degree master program demo. And as you know, it's a 100% job-oriented and job guarantee DevOps and cloud training. Today, we are starting with Class35, which is going to run for 220 hours. And you're going to be studying DevOps with Linux and cloud services. 19 weeks of classes from January 13 to May 31st. 7 weeks of interview preparation and job assistance, so a total of 26 weeks. 9 hours of lecture per week, 6 hours of live, in-class session, and 3 hours of video. Now, what is the output of this course when you finish? When you finish, you can work in any of these categories: DevOps engineer, cloud engineer, infrastructure, site reliability, platform, and most importantly, you are a subject matter expert. Now, the way we run the program such that by the time you graduate, you have gained hands-on experience approximated to over 4 to 9 years IT, DevOps, and cloud experience. It's okay. So please take note, it's very important. Now, this course has a lot of projects. We are going to be looking at what I've shared with you guys. This is project 1, which is a Jenkins integration project. We have project 2, project 3, but the entire course is project-based, project 4, project 5. The entire course is project-based. Is it okay? Now, so this is the DevOps life cycle. This is how the DevOps diagram looks like. Now, we are going to be covering many modules in the program. Modules in the program. That's what we're going to be covering. Let me see something here. Syllabus. We're going to be covering, multiple modules in this program. And what are the modules? From Linux to Bash shell scripting to Git and GitHub, GitLab and Bitbucket, Maven, JBoss, Tomcat and Apache, SonarQube and SonarCloud, Nexus, Jenkins, Docker. You'll be covering Kubernetes, Ansible, AWS, GCP monitoring. Okay, we have Terraform, interview questions, resume lines, and project. And again, your class is starting. This is January 13th, 2024. To May 30th, May 31st, 2024. The fee for the course again is $3,600. Now, We also have commonly asked questions and answers. Admin, can you share the link? Commonly asked questions and answers. Can you share the link for question and answers? Okay, good job. So we have commonly asked question and answer. People always ask us some certain questions like, Prof, how can I contact you guys? This is our website. This is our WhatsApp URL. This email address. How to pay fee@mylandmarktech.com. Okay, if you want to know those that have succeeded, mylandmarktech.com/success. We have over 1,000 people that have succeeded who are working. Here are our official phone numbers. Who can study the Landmark DevOps e-degree master program? Who can study it? Anyone who have graduated from high school, who is at least 18 years of age, 18 and above, you can do the course. Individuals with a passion for technology and keen interest in DevOps practices, automation, and infrastructure management. Individuals looking to make a career change in technology field, specifically in the domain of DevOps, suitable for those who prefer or require remote learning opportunities, providing flexibility for individuals with various commitments. As a matter of fact, anyone can study the course. I mean, I want to add here, okay, anyone who is interested can study the program regardless of their ages, okay? But again, we always recommend high school grad with at least 18 years. Take note. Now, for among our graduates that have graduated who are working, the oldest is 71 years. The youngest is 19 years. Those that have graduated who are working already. Now, when is the next class starting? Class 35 is starting on January 13th. And here's the timetable. Monday, Tuesday, Saturday, 7 to 8 p.m. EST, which is New York time. People keep asking us, I don't have an IT background. Can I still do this course and succeed? The capital answer is yes. We take you from zero IT background to become a highly skilled and professional IT personality and DevOps engineer. As a matter of fact, over 95% of our graduates working today had no prior IT background before joining. The course is designed with a step-by-step learning path, starting from the basics and gradually progressing to more advanced topics. This approach enables a smooth transition for beginners. Now, what is the average salary of Landmark trained DevOps engineer? The average is $150,000 a year for a single job. And today our highest paid engineer is making over $700,000 a year. Now, take note that we also have, you can start making millions of dollars via our coaching program that helps engineers start their own IT businesses and companies. Professor Lega, which kind of job can I do after finishing this course? Since you have said the course is 100% job guarantee. Now, this course is 100% job guarantee because we have over 14 jobs that you can do when you finish. One course, 6 months, 14 jobs that you can do. As a matter of fact, it has increased to about 20. Wait a minute. The list is increasing. Can you see that? Now, these are jobs, some of the jobs that our graduates are working on already. Some of them are working as DevOps engineer, DevSecOps engineer, cloud engineer, AWS cloud engineer, platform engineer, infrastructure, Kubernetes engineer, okay, senior IT recruiter, technical project manager, production lead, build and release engineer, site reliability engineer, cloud architect, containerization specialist, automation engineer, security DevOps engineer, cloud migration specialist, cloud data and data engineer, cloud solution architect, DevOps trainer, continuous integration specialist, cloud. So you can see that the list is long. As a matter of fact, today we even have somebody who is vice president for application support. Now, with all of this, Mr. President, Professor Lega, how much is my fee? Is it $20,000? Is it $50,000? Because you shock you to know that this course we have pharmacists who have taken loan and studied in countries like America, and they owe the government over $80,000 US. They have abandoned pharmacies to come and study in Landmark. Professor Lega, how come that is happening? How can somebody abandon pharmacy? Nurses are abandoning, accountants, CPAs, name them. They are all coming in to join the landmark program. You see what I'm saying? Now, it is part of the reason is because even though the fee should be more than the fee for pharmacies, we are charging a giveaway fee. How much is it? The fee is $3,600 and can be paid in minimum installment of $700 per month with $800 for the first month. You can pay the complete fee upfront. Please type your name and class as payment references and send screenshot to Prof. Lega on these numbers. Now, refrain from making Zelle or Cash App payment using phone numbers. Please use email only for transaction. Okay, because you can use phone number, don't use phone number. Now, Professor Lega, I'm in Cameroon. How do I pay my fee? You can use MTN Momo transfer. These are the numbers. Now, I am in Nigeria. Is there? Yeah, we have Landmark is registered in Nigeria. Landmark Technology Nigeria Limited. So we have Landmark registered in Nigeria. Okay, we have scaled down the fee to 2.5 million for it, you know, which is 500,000 a month times 5. How can I pay my fees? You are in Canada. You can use Interact, Zelle or Cash App. Those are the options. Or you can send a PayPal invoice to this. Okay, send payment. You can equally pay via PayPal, but request for an invoice before you pay using PayPal. Now, so please take note. I cannot join Class 35. Is there any other class coming? Yes. Class 36 is going to start on April 13 to August 24. What is the duration of the course? 4 months plus free boot camp. Which kind? Now, please, the boot camp we offer, we have had people contacting me from India. Like, we want to get your student come and do boot camp with us. And so they charge up to $10,000 for boot camp only. But we are giving more than what you can get in India for free. I mean, more than what those Indian guys can give you, we give, you know, and they are charging 10,000, we give it for free. Professor Lega, why are you guys so generous? Why are you so generous? Now, the reason is simple. Our vision is to get 1 million Black people in the tech world in the next 10 years. We need 1 million Black folks who are going to take over Silicon Mountain, take over the entire tech world in the world. I think that, you know, because politicians have failed to bring the African continent to the limelight. So we need to bring Africa to the limelight via intellectual capacity deployment, deployed and running in production. Now, which kind of computer will I need for the course? A computer with at least 8 gig of RAM is required, 256 gig or 500 gig of hard drive, 14-inch monitor. Take note. Now, course bonuses, Professor Lega. This program, what are the bonuses that I'm going to get? Number one bonus is that there are so many flyers that you may have received some. I know there are some people in this class now who have come not to attend this boot camp, but to share their flyer that I'm also running IT program. Come to my school. I'm also now, the one thing again I want to let you know is that there are so many IT schools, you see them out there. But again, if you are thinking of a serious transition, then there is landmark technology that have been designed for you and for you alone and your family, your friends, your loved ones, your community, and name it. Now, course bonuses, number one, bootcamp that comes with helping you to set up your resume, LinkedIn profile, and running interview reviews, providing academic and work references, daily interview sessions, 100% job-oriented, hands-on project, continuous learning resources, collaborative learning, industry standard tool, lifetime access, career development, access to course material, latest industry trend, and most importantly, the grace of God at work in landmark technologies, both to will and to do of his good pleasure, raising young men and women from nowhere to become somebody. Now, what have we seen in landmark? What is the good news so far? What is the good news? Why are we excited? Why am I telling you that this is a 100% job guarantee program? Now, Landmark 100% job-oriented DevOps e-degree master program with Linux, AWS. Now, please, you are going to see flyers. Today, I see a lot of flyers that have just copied Landmark and paste. If you see those flyers, don't confuse them. They are not Landmark flyers. If you don't see Landmark technology on the flyer, they are not Landmark flyer. I was going to make this information well known because just this week we have students who have joined the program and they are sending us contrary flyer that have just copied our information exact, and all they change is just the name. That's all they were able to change. The rest of the information is the same. Please, if you see such flyer, it did not come from us. It never came from us. Now, we have trained and graduated engineers from backgrounds including university professors, pharmacists, chartered professional accountants, chartered CFA, lawyers, accountants, bankers, entrepreneurs, nurses, registered nurses, nursing assistant, drivers, scrum master, factory workers, personal support worker, disability workers, students. All of them have come to Landmark and their life has changed. So please, you need to subscribe to our YouTube channel for more information. But now, I was going to just explain something to you guys because we have noticed that a lot of folks have taken our flyers and they have changed just the title. They changed the title and they share the rest of the information. And people are asking, Prof, some of them even tell them that they are working for Landmark. They are not, please, if you don't see Landmark on the flyer, they are not part of Landmark. Be warned, beware, be warned. This is only to inform individuals who may be here now, who are trying to, get Landmark information and take it out there, deploy it in a low standard way, and people go out and say there are no jobs for engineers, there are jobs. So please, I just have to throw some light on that so that if you meet such individuals, don't succumb. Please, it's important. Very, very important. I have to just make this point clear to you guys so that you don't get confused. Okay, now, the Landmark, let me come back here. If you see the Landmark flyer, you will see something like this. If you don't see a flyer like this, I've seen flyer that they just change only the name and the contact. They just come and scrub the name out and the contact, that's it. Everything is the same. Please, if you see such flyers, be very careful. Very, very careful. I had to make this announcement here because, I've seen a lot of things going on and people come back to us and they thought it was us. Please, they are not us. They are not Landmark. Okay, now, I know I'll take 2 questions. We'll go for interview and we'll be switching over to the testimony session after from 1 p.m. testimony is going to start. Now, most of your questions will take place during the testimony, graduation, and matriculation because most of the questions you have, testifiers will answer them for you. So let me take a question from, I see one hand, but you cannot ask a question if you're not on video. So Habiba, if you're Habila, for you to ask any question, you have to be on video. So since there's nobody wants to ask question who is on video, okay, Oladele Michael, let me take one question because at exactly 12:50, I'll end the session, 10 minutes of break, we'll come back into the graduation, matriculation, and testimony. Yes, Michael, can you unmute yourself?
Yeah, good morning, Prof. Thank you very much. It's a great opportunity to be in this class. Actually, my wife is in class 34, and I know that our transition is going smoothly. One of the questions I want to ask is in the flow diagram that you drew earlier, and I know we are still going to go through all this later on in the course, but this is also a preamble to the real course that we're going to, what we're going to be doing in the program. So I want to ask in step number 3 and number 4 and number 6, you from Jenkins to Maven, is it a two-way communication? From Jenkins to SonarQube, is it a two-way communication, like back and forth?
Okay, that's a very good question. It's a one-way communication. Jenkins connect with SonarQube to execute code quality analytics. That's what happened. Same for Marvin. Okay, and as we get into the course proper, you will see how Jenkins is integrated into, or how Marvin is connected to Jenkins and how we configure the integration. You are going to be able to look at that regulative piece, but that's a good question. Yeah, Miss Ray, can you ask your question?
Thank you. So I wanted to ask you if you could go the previous slides with regards to computer requirements.
Okay.
I just wanted to take a screenshot so I know exactly what I'm getting at the store.
I get it. Okay. Computer requirement. Let me check that out. What kind of computer is needed? Let me see. Can you see the computer requirement is it here? You need 8 GB of RAM, 256 GB of hard drive. Okay. We'll take the rest of the question as we come back. Let's have 10 minutes. Let's have some few minutes break. I'll be back at exactly 1 p.m.